chemical changes lab today. And the lab is in several parts, and each part has its own sort of directions, data table, questions. So make sure you complete everything within each part as you go along. So we're going to start with part A, kind of go through what you guys need to do, and then I'll kind of let you work on your own as you go from there. So part A says, look at the samples of the substances water, table salt, table sugar, ethanol, wax, copper 2 sulfate, pentahydrate, and mineral oil that are listed in the data table below. So what you'll see on each of the 3 counters, so side counter over here, back counter, side counter under the window, is you're going to see bottles where the bottle and the lid are both labeled with the chemical that's in them. And then there's going to be a little scoop, one like this, or a little metal scoop, and on the scoop it has the name of the chemical. So before you do anything, make sure that all of those match before you do anything about that, okay? You are going to take a small sample of each of those substances in a little piece of aluminum foil. So if you just, cut a piece of aluminum foil off the roll, you can cut it down into smaller pieces. About like that is about the size that you want for your sample. And rather than being completely flat, we want it to be slightly curved. And all you need to do is just sort of mold it around your knuckle a little bit so you have a little tiny bowl. That's as much as you need, okay? Every person, I don't care if there's somebody behind you waiting for the same sample, you're gonna open the bottles. You're gonna take the cap and put it top side down, because what happens if we put it with the bottom side down? If there's junk on the counter, now it's back in the bottle, right? So you take the cap, either hold it in your hand, or when you put it down top side down. Take the little scoops and you take a small scoop of the solid and you put it in your little well. You put the lid back on, put the spoon next to it, and now it's ready for the next person. The person behind you says, hey, I'm using that. You put the lid on it anyway. Next person comes up, they take the lid off. Put it down, scoop it out, they put the lid back on, next person gets it, okay? The reason we do that is you're using several solids today that look just like sugar. And if we start having caps and things all over the counter and the spoons go all over the place, people are gonna be like, oh yeah, that's fine. And then all of a sudden they're gonna put the salt spoon in the sugar or the salt lid on the wrong thing, and now everything's cross-contaminated and gotta clean up and start over. So we don't wanna do that, okay? So one lab rule, we always read our labels first. Whoever opens the bottle, solid or liquid, is responsible for closing it. If there's any kind of dropper spoon that goes with it, you're responsible for making sure it goes back with that container, okay? So for each of those substances, you're gonna have a little, a little square of aluminum foil with each of those substances on it. So you're gonna get one with just tap water, one with table salt, one with sugar, one with ethanol, which is alcohol, one with wax. We have a container in there that just has some little chunks of wax in it. The copper 2 sulfate is the bright blue one that's back there. And then mineral oil is a liquid. For the 2 liquids, the ethanol is in dropper bottles. You can just dropper straight in. For the mineral oil that's in a white bottle, we have little glass droppers that you can use to sort of suction it out and put it in your container. Again, with the liquids, you don't need more than a couple of drops in the bottom, okay? So as we fill out the data table, the first thing you're going to describe is what is its color. Is it white? Is it blue? Is it clear? Colorless, right? Then you're going to identify the form. Is it a solid? Is it a liquid? If it's a solid, is it a crystalline solid, meaning it has little pieces, or is it a powdery solid, meaning it's really fine, like flour or powdered sugar? Open them up and smell them. In chemistry, we never smell anything by shoving our nose into it, right? You waft it towards yourself. That's just in case it smells really bad. So if there's no odor, you can put no odor. If it has a smell, we want you to describe it, okay? I've had smell descriptions of sweaty gym socks, grandma's attic, hospital, right? Whatever kind of image or thing that smell conjures up, we want a descriptive odor, not just yes, it has an odor. No, we want it to describe what it's like, okay? So that's the first thing. The last one, it says behavior upon heating. So it's important to note whether a substance melts when you heat it up, whether it burns, catches fire when you heat it up, or it decomposes. It comes apart into its components when you heat it up. So we're going to take that little aluminum foil square, we're going to add our little crystals to it. After you've made all your observations, then we're going to see what happens when this heats up. So the way you want to do that is keep your foils sort of close to flat on the table. So the liquids will be a little harder. You want to light your match. Easiest way to do that if you haven't used paper matchbooks before is just sandwich the match in the back, pull it, and then it'll light nice and easily. Let the match actually get lit so it'll stay lit. Then put that lit match on the foil next to your sample. Okay? You don't want to just sort of hold it next to it because you'll burn your fingers, so we want to set it next to it. And then you want to observe what happened near your lit match. Okay? Did it melt? Did it burn? Did it catch fire? Right? Did it seem to decompose, turn black? Were there color changes? Were there smell changes? So we gave you a nice big space under heating to kind of write any little observations you see happening. Did the match just go out? Did nothing happen other than the match went out? That's an indication too, okay? So once we've done that, you're done with part one. You've gotten all your samples, you've made your observations, you've done your heating, we're done. Before you move on to part two, we're gonna clean up, okay? So cleanup looks like this. Burned matches. They go in trash can, okay? All your little foil packets of solid, you're gonna come back here, and there's 2 containers in our waste fume hood today. One says aluminum, no blue solids, okay? It says aluminum bowl, no blue solids. Any aluminum foil pieces, any solids that are not blue in color, all get to go in here. So my little aluminum foil square that has the sugar on it, the whole thing goes in there. Because it's a white solid on the aluminum, that goes in there. This one says no blue solutions. So any liquids that you have, the alcohol, the mineral oil, we're going to dump those liquids in here. And then the aluminum foil goes in the aluminum foil container. Okay? We're missing one because we should have one for the blue solution, so I'll go ask Elsa for that. There should be a clear glass. Ah, there it is. It's over here. Move it on this side. Okay. So anything that's blue solids, there's a beaker. If it's a liquid that's blue, goes in the container. Okay? And the reason for that is, remember I said this blue one was the copper sample? Anything that has a metal in it like that, a heavier metal, we can't throw down this sink, we can't throw down the drain the same way we can throw silver or sugar and salt, okay? So anything that has the copper in it, we have to dispose of separately, so we want to keep it away from the rest of the waste, okay? So it's really important that as you're cleaning up, anything that had this blue crystal in it comes over here, everything else goes back there, okay? All right, so that's part A. Pretty straightforward, nothing too crazy going on there. Questions for part A are fairly straightforward. It says, which of the above might be easily confused if you were to distinguish them by appearance? If you were given an unknown that was one of the materials, how would you test it? If you were given an unknown solid that was one of the materials, how would you test it? So in those questions, it says, be specific. What tests would you perform and what results would you see? So if you write an answer, I would heat it. That's not a complete answer. I would heat it, and if it were salt, I shouldn't see a change. If it were wax, it would melt. If it were sugar, it would burn, right? So here's the test I'm gonna do, but what are the possible results I would see depending on what solid I have? Okay, so make sure you have a complete answer there. Part B. Part B, you're going to get out your test tubes. Okay? Let me borrow, somebody have their drawer open. Those test tubes for a second. All right, so part B, you guys are going to use your test tubes. Okay? So part B says it's about solubility and miscibility. If a solid substance, the solute, dissolves in water, the solvent, then the substance is said to be soluble in water. Some substances are very soluble, some are only slightly soluble, and some are insoluble, meaning they don't dissolve at all. So what we're going to do, if you look at that little table, is we've got 4 solids: table salt in plain water, table sugar in plain water, wax in plain water, and then the copper sulfate in the plain water. Okay? Anytime we're in lab and water is part of our reaction, we never want to use tap water. Okay? And that's because tap water has other minerals and things dissolved in it. It's not just water. So in our classroom, the sink on this side of the room, there's a separate faucet that has a little white handle and a little white tip. That sink faucet dispenses distilled water. That's the one we want to use anytime water is part of our reaction. So because you're going to use quite a bit of distilled water in lab today, you might want to take one of your little beakers, go get yourself a sample of distilled water, then you can use that throughout the lab. Okay? It says take 4 of your test tubes, fill them about 1/3 of the way up with distilled water. I usually go with sort of the height of the test tube rack, sort of fill it up to there with distilled water. And then it said place a few crystals or very small scoop of each of the solids into the test tube. So salt in the first one, then sugar, then wax, then the copper sulfate. So again, open it up, take your scoop, put it in your test tube, close it, put the bottle down. So that means you're going to have your test tubes of water, you're going to bring it over to the side tables, put your solids in, then bring it back to your station. You don't want to do what I did, which is grab the bottle and the scoop off this table and bring it back to your station. Because if you do that, right, you're going to use it and set it aside. Then everyone else is going to be looking at the counters going, where's the sugar? It's gone, right? It's because you have it at your table. If we leave everything on the sides, then everyone can find everything, okay? There's 3 sets of everything. Shouldn't be a backup too much at each spot. We're going to go through that. Then it says, stir the mixture for several minutes with your stirring rod or for 1 minute on the vortex mixture. So you guys have a glass stirring rod, it's that glass tube in there. You can just go in there, I'm going to use this, right? You just go in there, stir it up, right? If you go from one substance to the next, you got to clean off the stirring rod in between. So damp towel, clean it off, make sure it's clean. Otherwise, you can use what we have over here. These are the vortex mixers. Like this, okay? Make sure they're on, and the little top spins around. If you put them on auto, it won't spin around until you press on it, and it spins around. You want to hold your test tube by the top over the opening. Take the round part of the test tube right in the center and press down. It's going to vibrate your sample in little like swirling motions, and it'll stir it up for you. The dial here changes how fast it spins. Okay? If it goes too fast, they're a little hard to hold on to, so you don't want to go too fast. Okay? Just put it on the vortex mixer, make sure it's mixed nice and thoroughly, bring it back, then you can observe it. Okay? So either method you can use for stirring, but stir them up, then observe them. Okay? It says, what are your observations? Did everything dissolve? Was there a color change? Did nothing dissolve? Is there still some solid left over, but it's less solid than you put in, so some of it dissolved, right? Those are your observations. Then it says, what is the solubility? Very means everything dissolved. Slightly means there's less solid than the scoop you put in, but there's still some solid that didn't dissolve. Insoluble means everything you put in is still there. Nothing dissolved, okay? Then you're going to do a separate little experiment that's similar to that in your graduated cylinder. You're going to go up to the 2 milliliter line with table salt. Then you're going to add the DI water till you get to the 4 milliliter line. And then again, shake or stir in your graduated cylinder. Make some observations about that. Okay? So the second part, we're going to deal with miscibility, which is dissolving of liquids in one another. You're going to need 3 clean test tubes in order to do that. Well, the group that I borrowed this from, they're going to use 4 test tubes for the first test, and they only have 2 test tubes left for their second test. So they're going to have to wash dishes in between. Remember, anything that's blue is going to go into the back fume hood back there. Any other liquids are going back into the beaker that's for liquids in that back solution. When we wash any glassware, whether it's test tubes, beakers, anything like that, we always want to dump out what's in them first into the appropriate waste container. Then we go to the sink and we wash them. Every sink is equipped with a squeeze bottle of already dissolved soap solutions. You can squeeze a little bit of that into your glassware. And then there's either sponges for larger glassware, or there's varying sizes and shapes of brushes. Okay? So for your test tubes, you might want to use the small brush, right? Get down in there, clean anything out. Give them a rinse in normal tap water. But when you're done cleaning, everything gets a final rinse with distilled water. We always want to rinse off any tap water because we don't want that interfering. And in this particular lab, tap water residue will create problems with some of the reactions we're trying to observe. So you wash in the tap water, then you go over to the sink with the distilled water tap, rinse everything one more time, okay? All right, so now we're ready to do the second part. And that says, in 3 separate test tubes, make mixtures that are water and ethanol, water and mineral oil, ethanol and mineral oil. Add about 1 to 2 milliliters of each liquid. Note that about 20 drops is a milliliter. In these big fat test tubes, a milliliter is barely past the curve on the test tube. If you have a skinnier test tube, a milliliter is the same as about your pinky height on your test tube. So you can kind of use those as guides to help you figure out how much liquid you want to put in there. Use different amounts of the 2 liquids so you can tell which is which if they don't mix together. That means if we're putting oil and water together, I might want to use 1 ml of water and 2 ml of oil. So I have different amounts so I can tell them apart. Again, mix the contents very well using the vortex mixers. Then allow the test tubes to sit undisturbed for about 3 minutes. Then make your observations. So you're going to put all the liquids in, you're going to mix them up, you're going to bring them back, you're just going to let them sit for a couple of minutes. Maybe while you're answering some other questions. Then once they've sat, then make your observations. So it says, are they miscible? Miscible means the 2 liquids dissolve in one another. They don't make 2 separate layers. If it's immiscible, it means you get 2 distinct layers. You can see a line in the middle of your beaker or the test tube where the 2 liquids separate. If they are immiscible, you're going to indicate which liquid is more dense. So where will the more dense liquid be in your test tube? Top or bottom?
Bottom.
On the bottom. And if you use different amounts, different volumes, you can tell, is the liquid in smaller volume the one on the bottom, or is the liquid in larger volume the one on the bottom? So that's why we're using those different amounts, okay? So then you're going to decide between water and ethanol, can you tell which is more dense? After you've done your complete experiment, you should be able to rank all 3 liquids in order of increasing density. So show most, middle, least, and then explain how you figured that out. So use your test results to help you figure that out. Okay? Once that's done, we are again going to want to wash everything. The mineral oil in particular, like any oil, it's very sticky. It likes to stick to the glass. It's going to take quite a bit of soap and quite a bit of scrubbing to clean that oil out. Dump the liquids in the back, wash them, rinse with distilled water. Now you're ready for part C. Okay? So part C is about whether what we're observing is a chemical change or a physical change. So the first one, we're going to fill our test tube about 1/3 with water again, right up to the top of the line. Fill a second test tube with about 1 inch of 1 molar hydrochloric acid. So just a little bit. And again, they're on the sides. Read the bottle. Make sure you have the right label. Okay. Then add a small scoop of baking soda. It gives you the formula there because that's what's on the bottle. Into each test tube. If necessary, shake or stir them. Okay. Record your observations in the table, and then determine if what you observed was a physical change or a chemical change. So remember, physical changes would be state changes. Solid, liquid, gas, it melts, it boils, right? Dissolving is a physical change. So if you put a solid into your liquid, it simply dissolves in. That's a physical change. Chemical changes, right? We would see evolution of heat or light. It would get warm, it would get cold, it might glow. We would produce a precipitate, a solid. We would see a solid sinking down to the bottom. It would look cloudy. We make a gas. We see bubbles forming, right? Or there is a permanent color change that didn't come from the color of one of our substances, right? We put them together and they turn yellow. And they both started off white or clear, right? So those are the things we're looking for. Next step, again, fill each test tube about 1/3 with DI water. Fourth test tube gets tap water. This is the one time we get to use tap water as a test substance. First test tube gets salt. Second test tube gets sugar. Third test tube is plain DI water. Fourth test tube is plain tap water. Mix them up. Add a few drops of the 0.1 molar AgNO3, that's silver nitrate, into each test tube. Stir it again. Record your observations. Now, the silver nitrate, if you look at it over here, it's in these little dropper bottles. Notice what happened to the dropper bottles. They used to be clear like this. What's happened over time to this poor little dropper bottle? It's gotten stained. Okay? That's because silver nitrate is what we call photoreactive. It reacts with sunlight and turns black. Which means, if you're not careful with this stuff, and you get it on your hands, and you don't wash it off properly, when you go outside and the sunlight hits it, you're going to have a whole new set of freckles you didn't know you had. Okay? I used to teach high school. You can imagine what high school boys would do with this. They used to write things on their arms with silver nitrate, then go outside and they'd have this little black tattoo for a couple of days. Okay? You do not want little black specks all over your hands or under your nails. Be careful using this or use gloves. Okay? A couple drops goes into each one of those test tubes. Okay? Again, silver is part of our heavy metal waste, so the silver waste is going to go in here as well. So those 4 test tubes that have the silver in them are going to come over here with the copper. Okay? So again, we're looking for, is it a physical change? Did it just mix together? Is it a chemical change? Do we see precipitates? Do we see gases? Things like that. Okay? All right. Last test that you're actually going to be performing in is our copper. So we have these little copper wires and we have tongs. Okay? It says sand the end of a copper wire until it is shiny like a new penny. So right now they're kind of cruddy. If we take, I don't know, there's sandpaper back here. If you take just a little bit of sandpaper, wrap it around here, and then just kind of go back and forth, it'll sand off all those little edges. And pretty quickly, I get that shiny new penny color, right? Nice, clean, shiny copper, okay? We're gonna heat these up in the Bunsen burners, okay? So, or does she want us to use the candles? Is that what the candles are up?
It was I think that's your call.
Okay, I'd rather use. Okay. So Bunsen burners, 2 drawers over here, one labeled Bunsen burners. That's where the burners are. One labeled burner tubing. That's where the tubing is. That is a really long piece of tubing. All right, that's that. Okay. So when you get to this point, I will help you set up your Bunsen burners and light them and adjust them correctly. But the first thing you want to do is get the tubing onto the end of the burner. It doesn't look like it's going to fit, but it's really soft. It'll go on there. And then the other end of the tubing goes on the gas lines that are in the middle of the table. Okay? The gas lines are the ones that are blue. So again, just shove it onto the end. Okay? When you go to light a Bunsen burner, there are 2 adjustments you need to make. One is this dial on the bottom. This actually regulates how much gas comes from the tube up to your burner. The other one is this little opening right here. If you grab the stem of the burner and twist it, can you see how a little opening opens up right there? That's letting oxygen in. The more oxygen in that you get, the better the combustion is, and it'll change the color of your flame. If it's clamped way down and you don't have enough oxygen in here, your flame's going to be yellow or orange. As you open up and you add more oxygen, the flame's going to turn blue. And that's what we want, is that nice blue flame. So when it's time for you to set this up, same as if you were ready to do the copper, I'll come over, I'll show you how to properly light it, how to set it up, how to adjust your flame. Okay? Once you've done that, all you're going to do is you're going to put the end of your copper in the flame. But copper is a pretty good conductor of heat. If I put the end of this copper in a nice high temperature flame, and I'm holding on to the end of it, I'm not going to be able to hold the end of this for very long. The tongs are for. Okay? So grab it as tightly as you can in your tongs. This might take a little finessing till it's not wobbling around. Go back and forth in the flame for a little while. If you take it out of the flame and you notice it changes color, you're done. It should only take a couple of seconds in the flame. We do not want to put the hot copper on the gray countertops. They'll melt. That's why there's tiles. Okay, so take your nice hot piece of copper, set it on the tile, let it cool for a couple of minutes. Then it says, once you've done that, sand a small section of the wire that was in the flame. So before we sort of sanded all the way around, now just sand off one little edge. That way you can see what the inside of the wire still looks like versus the outside change that you might have seen. Okay? And it says, write your observation. Are those changes chemical or physical? The last part of this lab is not actually an experiment that you're going to do. It's a demonstration that I'm going to do. It's going to be in the back of the fume hood back there. Again, when your group gets to that point, same as V, we're ready for the iodine. I'll go back and I'll walk you through the demo that's back there. Okay? So we should sort of space out naturally so that not everybody is getting to the iodine all at the same time. Okay? We've got questions for each. At the end, we've got some questions on physical and chemical properties, distinguishing those kinds of things. You will notice there was a slight printing error in your books, and it's dealing with next week's lab. The back page of this lab and the first page of the next lab are on the same sheet of paper. We've actually re-photocopied the first page of next week's lab for you, so we'll give you that page separately next week, okay? So don't worry that you're turning that in. We'll give you another one next week, okay? So that's your lab for today. It's a lot of sort of doing experiments, writing down observations. You are gonna have to do dishes a couple of times in between to clean things up. I'll be walking around, kind of keeping an eye on you, asking questions. Every time you finish a section and you're cleaning up, remember if it's blue or had the silver in it, goes in the fume hood on this side. All other solids and liquids go in the back. What is the only thing you get to put in the trash? Burned matches. What is the only thing that should be going down our sinks? Water from washing your dishes. Okay, no chemicals ever go down the sink. Okay? All right, you guys are good to go. Yeah. If you have a partner, is anyone else missing their partner? Do you have any other solos today? Why don't you guys be a group of 3 then? Okay, cool. So that you're not working. Okay. Okay.